Hi guys, welcome back to another video. Thanks to this comment, and because of this comment, I found a very fascinating question to show you guys. It is the 2021 HKDSE M2 question 9. So I'll just start explaining. B tells us to let g of x and h of x continuous on R such that g of x plus g of negative x equals to 1 and h of x equals to h of negative x for all x in real numbers. The question asks us to prove the integral from negative a to a of g of x times h of x dx equals to the integral from 0 to a of hx dx for any x in real numbers. How do we even start solving this question? Well, why don't we let a simple substitution? We let u equal to negative x. Okay, so if we let u equal to negative x, then we know that du will equal to negative dx. And we also need to change the bounds here. So, when x equals a, u will equal to negative a. And when x equals negative a, u will equal to a. So we can change this all with respect to u. So then the integral becomes the integral from a to negative a of g of negative u times h of negative u negative du. How do we deal with g of negative u? We know that the given information tells us that g of x plus g of negative x equals to 1. So g of negative x equals to 1 minus g of x. But this is u, but it's fine, it's just a random variable. So then we can change this into 1 minus g of u, and h negative u is just h of u. So then we can change all of this. Equals to, oh, one more thing guys. This negative can be used to swap the bounds of integration. So it's just negative a to a. Since we use this negative to swap the bounds, this is just 1 minus g of u multiplied by h of u du. Okay, so from here we can open the brackets to let it be negative a to a of h of u minus g of u times h of u du. From here we can just separate the integral. So it will become the first integral from negative a to a of just h of u du minus the second integral from negative a to a of g of u h of u du. We know that this equals to all of this, but this is variable x and this is variable u. But then that's fine because we can just change this u to x. So that if we do two steps at once, change this into x in your mind, and then you see this is the same as that. So then we can move this to the left hand side. So then it becomes 2 times the integral of negative a to a of g of x times h of x dx. This will obviously just be equal to this. Okay. To figure this out, we just need to divide the two. So then we know that this equal to 1/2 times this. Look at the given information. We know that h of x equals to h of negative x. So then that must mean that h of x is an even function and the bounds are symmetric. So then this will obviously be equal to, without the 1/2 now, just from 0 to a of h of x dx. And we proved it. Now we can figure out c. So now we can use the formula that we proved from b to solve c. And this states that it has to be from negative a to a. This is negative 1 to 1, which basically means a is 1. And then we need g of x times h of x. So that means we need two functions multiplied together, where g of x plus g of negative x equals to 1, and h of x equals to h of negative x. So let's think. Let's first work on h of x. Will equal to. There is a very obvious even function in this integral. It's x squared over square root x squared plus 1. That's obviously even. You don't even need to think about it. So h of x can just be x squared over square root x squared plus 1. That leaves g of x being equal to, so without the x squared and without this, it's just 3 to the power of x over 3 to the power of x plus 3 to the power of negative x. Let's test. We need to test if g of x plus g of negative x will equal to 1. So we know that g of negative x will just be, you just sub all of these x's into negative x, so then it will become 3 to the power of negative x plus 3 to the power of x on the bottom. On the top, it'll just be 3 to the power of negative x. Now let's take a look. If we just swap the order of this, the denominators will be the same, so we can just add them together. And 3 to the power of x plus 3 to the power of negative x is the denominator, so it's just 1. So then our guess was correct. These are the correct functions. So if we use the formula, then it will be equal to, from 0 to 1, of h of x, which is just this, x squared over square root x squared plus 1 dx. From here, we can use integration by parts. So I will change this integral into the integral from 0 to 1 of x times x over square root x squared plus 1 dx. To use integration by parts here, we can simply just let u equal to x and v derivative just equal to this. So u equal to x and v derivative equals to x over square root x squared plus 1. Obviously, u derivative will just be 1, and v will be, if you figure this out by yourself, it will just become square root x squared plus 1. Very nice. So if we just use integration by parts, it will become u times v, but we still have the bounds. So it's just x square root x squared plus 1, going from 0 to 1, minus the integral from 0 to 1 of u derivative times v, which is just square root x squared plus 1 dx. Let's first figure out the first term. If we substitute 1 in, this will be 1, and this will be square root of 2. If we substitute 0 in, this will all be 0. So the first term is just square root of 2. Minus the integral from 0 to 1 of square root x squared plus 1 dx. From here, we can do a trig substitution, where we let x equal to tangent theta. So dx will equal to sec squared theta, d theta. We also need to figure out the bounds. So when x equals to 1, we know that theta will be pi over 4. And when x equals 0, we know that theta will be 0. So these are the new bounds. So it becomes square root of 2 minus integral from 0 to pi over 4 of, we know that tangent squared plus 1 is sec squared. If we put that in a square root, it's just sec theta, times dx, which is just sec squared d theta. And then this is just sec cubed. So then it's square root of 2 minus integral 0 to pi over 4 of sec cubed d theta. So for this, I'll just show you the formula, because next time I will specifically show you guys how to solve sec to the power of 3 of theta, and I'll show you the general form of sec to the power of n theta. So I'll just write the formula. Then it'll become square root of 2 minus 1/2 times from 0 to pi over 4 equals square root of 2 minus 1/2 times, if we substitute pi over 4 in, then we know that sec of pi over 4 is just square root of 2, tangent pi over 4 is just 1, and then plus ln of, we already figured all of these out, so it's just square root of 2 plus 1. And we don't need the absolute value anymore because this will always be positive. Minus, if we substitute 0 in, this will be 0 because tangent 0 is 0, and if we substitute 0 in here, this will become ln of 1. Ln of 1 is 0, so overall it's just minus 0. It's square root of 2 minus 1/2 times all of this. So 1/2 square root of 2 minus 1/2 ln square root of 2 plus 1. And we know that square root, this is basically saying 1 times square root of 2 minus 1/2 times square root of 2. So it's just 1/2 times square root of 2. So equals 1/2 square root of 2 minus 1/2 ln of square root of 2 plus 1. And that is the final answer of the 2021 HKDSE M2 question 9. Thank you guys so much for watching, and if you like my previous videos and this one, please consider liking and subscribing. If you want to master something, teach it.